I would like to think rational numbers as a birthday cake that you're eating. Let's assume that this birthday cake has a total of 4 slices and you're eating one of them. Then you can express that as 1/4. So 4 total slices and you ate one of them. And if we wanted a more formal explanation, it would be that any number that you can express as a divide a over b. Any number that you can express as a over b would be rational number. So we call a, the top number, numerator, and the bottom number, denominator. So you can just memorize it as numerator over denominator. That's it. We can put rational numbers in 3 categories: proper fractions, improper fractions, and mixed numbers. So, proper fractions are fractions that numerator is smaller than the denominator. So the top number is smaller than the bottom number. For example, 5/7. Another example would be -2/3. So when we see a negative, we can just disregard that, because that negative, as we learned from the previous videos, belongs to the whole fraction. So it could be negative here, negative there, it doesn't matter, right? Another example would be 6/13. Improper fractions are the opposite of proper fractions, where the numerator is bigger than the denominator or equal. So top number is bigger or equal to the bottom number. An example could be 5/7 or 7/7. Again, a negative example could also work. -12/10. Or simply 8 would work, because it's technically 8/1, and 8 is bigger than 1. And mixed number is where we have whole numbers and fractions. An example to mixed numbers could be 4/1/2, or 2/3/4, and it could go like that. Here's a question that we can solve together. Which of the following are proper fractions? Now remember, proper fractions are where numerator is smaller than the denominator, so the top number is smaller than the bottom number. 2/7. That works because 2 is smaller than 7. -1/3. We don't look at negative. Still, 1 is smaller than 3, so that works too. 9/4. 9 is not bigger than 4, so that doesn't work. We have 18/19. 18 is smaller than 19. That works. We have a whole number here. We don't even need to look at that, so that doesn't work either. Now let's solve a question together. If following is an improper fraction, what is the smallest possible natural number that can replace the square? So we have square over 8 here. And we want an improper fraction. If you remember, an improper fraction is where the numerator is bigger than or equal to the denominator. So top number is bigger than equal to the bottom number. So we're looking for natural numbers, and natural numbers are basically 0, 1, 2, 3, and it goes to infinity like that. But we want an improper fraction, so we can technically write 8, 9, 10, 11, and it keeps going like that. But the question is asking for the smallest possible natural number, and the answer to that would be 8, because it could be equal, right? So our answer is 8. Okay, now let's do a little bit more complex question. So we're solving for x. Before we start, we can do a little bit of a simplification to make the calculation easier for us. So we can divide these both sides by 8, and we would get 2 here, and this would be 1. And now we can do cross multiplication like this. So it's 3x minus 2 equals 2 times 5 is 10. We can add 2 to both sides. We get 3x equals 12. And then we divide both sides by 3. Which gives us x equals 4. Now that we know the difference between proper fraction, improper fraction, and mixed numbers, let's see how we can convert between improper fractions and mixed numbers. Now, here we have on the left an improper fraction, 26 over 6. Now, if we wanted to convert that into a mixed number like the one on the right, we can just simply do this. Divide 26 by 6. We have 6 times 4 is 24, and we have a 2 remainder. So 4 whole 6's inside 26, so we write that, and we have 2 remainder. We write that on the numerator, and the denominator will be same, over 6. Okay, now let's do the opposite, turning a mixed number into an improper fraction. Now, to do that, we're basically just going to multiply these and add these. So, we're multiplying 3 times 9 plus, we're going to add the numerator 4, and the denominator is going to be the same. So, 3 times 9 is 27, plus 4 is 31 over 9. That's the answer. Okay, here are more examples. You can pause the video and solve it for yourself. So 51 over 7. It's an improper fraction. We're going to convert that into a mixed number. So to do that, we can divide 51 with 7. Let's divide that. We have 7 times 7 is 49, and we get 2 as a remainder. So now let's write that into a mixed number. So we have 7 whole numbers. We have 2 remainder, so it's 2. And then the denominator will still stay the same, so it's still 7. Now let's solve the next question, a mixed number. Now be careful here. If you were just doing as I told you, just multiply this and then add these two, which is the rule that I taught you. So you would do this, -2 times 6, and then plus 1, and then denominator stays same. So you could just say it's -2 times 6 is -12, plus 1 is -11 over 6. But that would be incorrect. Why? Because, as I told you here, the negative here belongs to everything, right? Not just the 2. So you can just pretend that there is no negative and then put the negative afterwards, right? So let's do that. Let's write the negative here. Now let's do 2 times 6 plus 1 over 6. We get 13, right? 12 times 6 is 12, plus 1 is 13 over 6. But don't forget we have the negative, so it's -13 over 6. Now let's find the simplest form of this fraction. To do that, you have to divide both numerator and the denominator with the same number. So let's just write it again here. 72 over 96. Now we can actually divide both with 12, but let's say that you can't see that right away. Well, you can just simply divide both by 2 and see where it goes. Now let's divide both by 2. We get 36 over 48. As you can see, we can still keep dividing by 2. Let's divide both of them by 2. We're going to get 18 and 24. We can still divide by 2, which gets us 9 and 12. But we're still not done yet. We can divide both by 3. So 9 divided by 3 is 3, 12 divided by 3 is 4. And the simplest form that we got is 3 over 4 because there is no common divisor between 3 and 4. So now let's say that you actually saw that you can divide both by 12. You can do that too. That would get us 72 divided by 12 is 6, and 96 divided by 12 is 8. So you would get 6 over 8, and as you can see, you can divide both of them by 2, so that would get you 3, and that would give you 4, and we got 3 over 4 again. So the same answer, whichever is easier for you. Okay, lastly, let's learn how to compare fractions. Now, this question says determine what symbol equal to, greater than, or less than to put between the fractions. Now, when you first look at these fractions, it's really hard to tell which one is bigger or which one's smaller. But one thing we can do is to get the same denominator, and then we can compare the numerators to see which one is bigger or smaller. To get to the same denominator, you actually need to find the least common multiplier, but we can just multiply them with each other. So we can multiply this fraction with 7 and this fraction with 4. So what we're doing is basically multiplying this with 7 over 7 and 4 over 4 here. 7 over 7 is 1 and 4 over 4 is 1, so it technically doesn't change the fraction, but it's going to make it easier for us to see which one is bigger or which one is smaller. So 7 times 3 is 21, and 7 times 4 is 28. And then on the right one we have 4 times 5, which is 20, and then 4 times 7 is 28. As you can see, we got the same denominator, 28 and 28, and now we can see that 21 is greater than 20. So here we can just write like this. Here we have another question. So now when you're doing the negative numbers, you will just do the same thing, but for now we're just going to ignore the negative numbers. You're going to see it why. Now let's multiply this with 8 over 8, right? And this with 9 over 9. So because you're multiplying with 1, the fraction doesn't change, but it's going to make it easier for us, right? Because we're going to get the same denominator. And now here we get 8 over 72, and on the right we get 9 over 72. Now here we can see that 9 is greater than 8, but remember we have negatives, so you can put the negatives now. When you do that, it's negative 8 is actually bigger than negative 9. So here we get this. Now let's solve one question where we have the numerators equal to each other. You can obviously try to make the denominators equal, but here we have the numerators equal to each other, and we can just judge by that. When numerators equal each other, the smaller the denominator is bigger the fraction. Now how is that possible? Well, basically I can just show you here. 13 divided by 10, you have 1 times, and you're gonna get 3 as a remainder. And now let's do 13 divided by 5. You're gonna get 2 times, 10, and 3 as a remainder. So you have 2 whole, right? 2 and 3 over 5. And here you have 1, so we can just 1, 3 over 10. And then on the other side you have 2, 3 over 5. Well, we know that these are both proper fractions, so they're less than 1, but we have 2 and 1, 2 is bigger than 1, right? So we can just, by looking at this, 5 is smaller than 10, so 13 over 5 is actually bigger than 13 over 10.